Oh, for this project? Yeah. Yeah, we're flying through. We're gonna get through this. We'll be done.
Let's crash.
Let's do it. Project 4, yeah. So last time in Applied Dynamics or Applied Mechanics 2, we picked a payload to get into space, and then we were trying to design some kind of de-spinning mechanism for it. So it's one of, I mean, space flight is pretty complicated. It is rocket science, like that's kind of, it sets the standard for how complicated things get. But each like individual stage is usually like a simple physical like engineering process. So last time, pick a payload, figure out what's that moment of inertia, and now that you have like that design variable set, our next goal is figuring out like how and why does this de-spinning mechanism work. That's kind of where we're at today, so we can wrap up. All right, so coming in to, do I still have, there we go. Project 4. So I still have this Tesla Roadster flying through space. I have some yo-yos that are de-spinning it. And both of them are 100 grams, so I need like 17 meters of cord to de-spin this Roadster. So first question that we have is like, so a lot of engineering systems, it's like, if you need a steel beam that is 10 square centimeters, just make it 15, and now things are better, right? Like now you have more strength, more force. But in this case, if I say, all right, I need 17.1 meters, let me throw 20 meters of cord on there, then what ends up happening is I was spinning 100, here I have like 100 to negative 100. I was spinning 100 radians per second. Now, because I added extra cord, I'm spinning negative 50 radians per second. Why is that happening? If my cord is too long, why does it spin my spaceship, my payload backwards?
So I think it has to do with conservation of momentum, or angular momentum.
Okay,
so,
yeah.
So the farther out you put the yo-yos, the faster they're going to spin.
Yeah.
And if you want to keep angular velocity constant, the payload actually has to spin in the opposite direction to preserve the original momentum.
Yeah, yeah. Okay. So what do we think about that description? About like, we have angular momentum, because like if we're kind of looking at it as like, remember we approximated the car as a box. This is going to be the Tesla truck Model 2. It's just a square box made of silver. So originally we have like one over here, a yo-yo over there. Everything is spinning like along that axis, right? Like rotating that way. So we have some hg is I theta dot of that payload plus 2m r squared theta dot of those yo-yos, if we think of them both as like moving. Once I release those yo-yos, they don't stop spinning. Like whatever my initial theta dot was, they're going to keep moving in that direction. They're going to keep moving with that theta dot, because there's no tension. There's no tension can't increase or decrease their speed that way. So then as they get further out, HG still had like that angular momentum is still whatever I started with, but now I theta dot p plus 2m. Let's do like our big. So we have like a lot more. And because angular momentum's a vector, it can have like positive, negative directions. How does that? There's also an equivalent way of thinking about this. If you just think about like torque, if you're thinking about like forces and torques, what would that be? If you think about like what's happening, if we look at the payload as like, yeah, so if we're kind of looking at it from the front, we have like tension and tension. So those yo-yos, they're creating a torque on it to slow it down. So initially it is going this way, but if you keep applying a torque, then you'll start rotating in the other way too. Torque isn't a constant torque, but it's a non-zero torque. So any torque is going to create angular acceleration. That's another way kind of thinking about it. What questions do we have left about like negative rotation rate? That one's usually kind of a weird thing of like, shouldn't it just stop rotating at some point? But no, okay. Everyone, this is like totally natural. Like obviously, I mean, on my last spaceship, that's what we used to do. We used to see this all the time.
Makes sense because the thing we're trying to do is stop it from spinning. But if you fail to stop it from spinning, when it's in the process of stopping from spinning, it's already like slowing down its angular momentum in that direction. It's going to zero and it's spinning the opposite.
Yeah, and then it'll keep going. All right. So then, what about what happened? How do we describe what happens when we change mass of yo-yos? Have you noticed anything yet? Ooh, pictures. What do we think? Let me check in and see what people think so far, and then we'll do some experiments and maybe tabulate data.
Half the time and length if you multiply the mass by 10.
Okay.
Ooh, factor of 10. So 10 to 1/2.
Yeah.
Okay.
Yes.
I took the mass and doubled it.
Did you try to change yo-yo masses? Or did you find?
For me, I have 1 second.
That's okay. Yeah.
Mass, which I did.
What did you find for like yo-yo mass?
About 50.
Because I don't like to. I like to.
You can set it up as like a mark, but like what I had.
Yeah, but
That's more work. It's not more work. You literally just push sell and then sell.
I like when I sell.
Oh, I think this scroll all the way to the top and run that very first.
Oh,
yeah. Now try running the rest of them.
It's perfect. Perfect. Yeah. I'm sending you some. Somebody's dad put this.
Oh, because you that one should be like your.
How big is the
Someone's dad is asked, why is the house inside?
If I was more creative, I would have that.
Yeah.
It says.
It really is.
Yeah. I love Resident. I don't even have an account. I just do Resident.
So that's, yeah, so now it's.
What don't you like about
So that's a good hypothesis.
Most like to come with
Bigger mass,
campus,
less
big
time.
lead funnel.
Yeah. Maybe. Yeah.
A little bit.
Could be. Yeah.
That absolutely is a reason.
It's not explained, it's just saying what it is.
well as the masses are increasing their distance from the car,
See how
they're
they're
getting
kind of coming off of it,
and
like
so that means the car has to be losing yo-yos for number one. Oh,
I
you
thought
want
you were,
number two?
no, I thought you were talking about number two, and I was like, Adam, what
Oh,
are you
no, crazy. Yeah, massive yo-yos. Yeah, just more mass gives the mass more angular momentum, so it makes the time longer. What else do you notice about this design? That's the part that's
Yes.
It's like I know, because I thought maybe you'd at least like look at
Much
or maybe you might know what brain like I said you said he does it.
So like as they release it, they unravel faster than the wheel is traveling because the wheel is slowing down and they're
Is that just because like the graphing picture specific, or is it like that?
part of it is like you're simulating like these first 1 to 2 seconds, but everything happens out here at 200 seconds. So we can change that to like 250. And maybe make like 1,000 slides. And now, yeah. So now you're starting to see. It's also like there's it's unraveling for so long, right? It's like
I have one required, it's like, one that they give you, they have to use, and then there's just four.
everything happens in the first like 50 seconds.
No idea. There's so many subsystems. I'm not sure I forget which one is what.
Screen shot is double the mass. Screen shot. It's like comparing to trash.
Or that's the same thing.
And like the more time the speed like that half. Like this
That's why you gotta do better like
All right, what did we notice about mass so far? Like mass of yo-yos at least.
increasing the mass decreases both the time and the length.
Decreased time length. Okay. Oh, come on. So let's go from 10 grams to 100 grams. My path changed. Now it's 50 milliseconds and I only need 9.6. Yeah, 9.6 instead of 17. So one way you could say like, hey, this is what I noticed, is like tabulate the results, right? Like, there we go. Speed. And now we can just kind of keep track. So 0.1 kilogram, 100 radian per second. Length was 9.64. Time was 0.05 seconds. And then go back up. Why are we moving so slow today? Come on. Then 17.15 and 0.09. Now we've got like a table of values that I'm starting, at least, and this is again like for Tesla Roadster. Where do we go from here? So we make mass bigger or smaller? What do we want to find out next? Even smaller? 10 times smaller? But, I mean, that's what we've done so far, right? Factor of 10. So 1 gram. 1 gram, now we're up to like 160 milliseconds and 30.5 meters of rope. What was it? 30.49. What do we think? Is it like linear relationship, log relationship, square root of the log of the exponent, sine squared? What do we notice so far?
There's definitely some sort of log of yo-yo mass to say the length.
Okay, yeah. So maybe 0.001. So maybe like L can do like 10, 20, 30. Or I put x-axis log scale, y-axis linear. And roughly kind of looks like a straight line, right? Like log of the... I had a postdoc that I worked with, and he said, what did he say? It was, oh yeah, log scales are for liars and cheats. like snake oil salesmen, because everything's a straight line on log scale. I'm like, but they're so useful. They're great. All right, what else we got? What else have you been working on?
Well, we could use it using. You're really gonna take screenshots of the graph?
That's exactly what I did, yeah.
Oh, just right click on it. Copy the image.
Huh? Oh.
You can download.
No, because I wanted the numbers to below it.
Download the image.
What do
What numbers?
where it spits out release time and length.
Oh, you want that?
I wanted the whole thing.
Oh, you
I
want
don't know, I
this?
did this pretty late last night.
Yeah. Oh, then let's do.
Wait, how did you find? Oh, never mind.
Well, like it's on the graph, you can see the.
Silence. Yeah, I'm pretty far gone at this point.
Add a title.
Uh-huh. Okay, buddy. Perfectly satisfied. I had said on, huh? It sounded like it.
Yes, they did, but it's
I saw people walking around with SpongeBob popsicles, so I just asked them.
Add a title to it like this.
It looks like every yes, you like an ice cream truck.
Then you can. Now you can copy the whole graph. You can like.
Put that under.
I know there was.
Oh,
Pull up a tab.
yeah. Give me a second. I was trying to. Come on. Give me the. Yeah, now I can say copy image and paste it wherever I want to put it. But I took that the same like print statement, I just put it, instead of printing it, I said plt.title, and now I can like show.
Well, that time by like one?
Backslash n dot one.
By one.
Oh, that's like just grabbing a value.
I'm not saying it wasn't
Yeah,
there for a
the
long
dot
time.
format.
Bracket.
Yeah.
Two.
At least if you're trying to like grab all the data all at once, like that grab plus.
They need a postal schedule. That's supposed to be.
What's point 2f? Floating point with 2 decimals.
Yeah. Yeah. So if you want more, you can put like 0.3 and look at 3 decimal places, and then you get like milliseconds, right?
Ooh. So it's not exactly what
Let's talk about the angular momentum.
Yeah.
I'm still trying to visualize it, it's just very confusing. So when you're going out, it's slowing down because they're getting further away. I get that.
Yeah.
When it reaches the equilibrium,
Or kind of that stopping point, like when it has 0 momentum, like angular momentum. When the payload has 0 angular momentum.
yes, once you reach that, like the point of release, because the yo-yo, I think it's just kind of going outwards though.
Yeah, they're going out, and like whichever way, like you were spinning kind of like this, the yo-yos keep spinning in that same direction, but they keep getting further away.
Look at your other graph for the spiral.
This way.
Yeah.
Yeah.
I'm confused how it changes direction though.
Why the payload changes
Yes,
direction?
yeah.
Because in order, so say you want to conserve your momentum at like, I don't know.
But I'm not talking anyway. I'm talking about,
Yeah,
I'm talking about logically.
No, I know. I'm saying like, I was just like putting a number to. I'm not.
Okay.
Say it's rotating at 10 meters per second. You want to slow it down.
Yes.
You send the yo-yos up, and they're gonna start spinning wicked fast. And like once that like exceeds the 10 meters per, once like those things are spinning faster than 10 meters per second, your payload has to spin at a negative rate in order to keep it at 10. Was that part of it right? A little bit.
I don't know, does that help
I guess.
a little bit? So another way you can kind of think about it is like the chords that you release, they create tension on your payload, right? And that tension, maybe it's not a constant tension, but it's always there. And those two tensions for both of the yo-yos is creating torque on your payload. And so the torque is slowing you down at first because you're moving one direction, but the torque is in the opposite direction.
Yes.
So once you come to zero, you're still applying torque because you haven't cut those cords yet. So there's still a torque applied. So you're still rotating. You'll keep rotating in that direction.
Okay.
Acceleration is still in that direction.
Alright. Yeah. I think.
Yeah, that's like that's more of like the Newton F equals ma kind of approach. If F is constant, A is constant, that doesn't mean that it will stop. It means that it will at some point come to a stop, but then you'll start going in the other direction.
Alright.
Yeah.
Okay. Thank you.
Yeah.
Yeah.
It rains only on the weekends.
It's a really good intuitive
Yeah.
process.
Completed this previously, and I can set that, if you increase the mass, and I was thinking about it, more to like, what equation,
Yeah.
the
Decrease mass.
Cause it's only been raining on Saturday.
That's what I'm saying. Saturday's
I think there was another 2 days actually during the week where it rained.
No, like this last Friday, I got, cause Richie's canceled, I got everything down. Let's go fishing, like, gusty ass winds.
You know, winds and.
Oh, you were thinking the opposite.
Yeah,
Increasing mass,
yeah.
increasing, like, turning the mass go up
Yo, that's
together.
actually cool.
Oh, interesting.
Oh, wow.
Yeah.
The draft is running good.
Start it again.
Okay.
Slow motion of three birds spinning.
Are you, so, in this part,
So now the mass is
have mass and mass, like we have mass of our
And they cut them off
people, and then mass of the yo-yos. The only thing I changed
You
was
see it starts going the other way.
Yeah.
I didn't look at, like,
Because-
what if I shed?
The whole time you're deploying, actually the whole time you're deploying the yo-yos, it's slowing down. And then
Yeah.
once it hits zero, if it keeps it slow down, it's gonna start moving faster.
How much?
Yes, because the torque is still object, like the angle is still.
Oh yeah,
Yeah,
you can
exactly.
see after it lets go, there's like a slight wobble to the device.
Yes. Yeah, because right here, the angle of that is still flying this way. And I just gotta put that in the weird one, kind of like this. Watch yourself.
That's actually really cool.
Yeah. You can try it.
Yeah.
maybe we can
do the same, like.
Oh, I found this other game actually.
Yeah.
And well, I think you were thinking like the payload would change.
Yeah, I think that's what
Maybe.
Mini Royale.
We saw how everything.
Battle Royale?
Yeah, we were like,
Yeah.
oh no.
Yeah, it's like Fortnite, and you're playing as
That's
toy
actually
voice
the
actors.
lesson, like there's learning science.
And it's got like a
The
team
lessons that
deathmatch
you
involved
remember
too.
forever are the ones where you were sure.
Yeah.
I don't know if this is.
And if you're right.
It seems like something in the system.
Yeah.
Looks like a
Like that'll stick with everything else.
Yeah, like I just submitted it.
Well, that looks like.
We were
Oh,
like,
yeah.
Sargus Hero.
Yep.
Oh yeah, that's what people, when you read the reviews, that's what people are referencing.
Dude, I have these games. I tried to play with it, like.
I didn't play this. That's what, okay.
Oh no, it's just. I saw someone try it for once and it seems like a good game to do. And like that, just try. I still don't know the last one. What else do we notice about these words?
We're gonna get there.
Right, slow it down. Oh, interesting. How did you find
Man, how did they explain that? Because I've got the torque right,
Okay.
Yeah.
I might just take the ESR because of the combination angular momentum and spinning weird. Yeah, so.
Yeah, that's what this is.
Yeah, I always be using my entropy generation band, I think you mean, with a couple words on it.
It's nice way to full of results.
I know you're not gonna like this.
One's about science, bro. You know,
Like, Loki, I hate this thing. I didn't know how to break it.
Well, you just did.
That one's showing how fast your payload, like whatever you're launching, how fast it's spinning. And then the time and your speech, like they're designed properly. So the red dot is the design line, like that L line, but the blue line goes past it and it keeps going down. So you have it. So you work on the stop. That's when you start spinning in the opposite
What
direction.
else do you notice?
If your course too cold. I don't know, we're trying to design it.
So, yeah, what am I supposed to write in this design?
Yeah.
Just when you
So the
change
question
the
is like if you add
starting
this
speed,
why do you start spinning backwards?
but doesn't that, it just changes the length.
It changes the time as well.
Yeah, does the length affect
I thought it was
the
together.
inertia?
Oh, it did with mine.
Can I check washer? Check washer.
0.52 and 15. There's this thing.
Yeah, yeah. And kind of like, if you think about it as a really short car, really long bus, it's like, well, the bus is heavier, partly because it's longer. So it's total volume does affect weight, but the distribution of mass around this spinning
If I
axis
decrease it,
doesn't really matter if it's a really long box or a really short, heavy box.
I actually get more time.
Maybe we can take question 3.
Yeah.
Yeah.
What are you discussing?
The change of the speed,
So this one is it on?
like just the starting speed.
That one, it depends on what axis you're talking about spin along. I was imagining like corkscrewing, so the driver is always looking at one thing but spinning in a circle. But you could think of it the other way, like the top of the car, not
My
like
values,
but everything's spinning.
the 30, my values.
Like donuts.
Yeah.
So either way, you just have to pick one. The main thing is we're picking like one axis and spin. You can get more complicated if you want to do like spinning along different axes.
For me, well, my
That's
maybe
it's
it's
confusing. Is it because of your,
like 46.
is it because of your,
Yeah, you're right, it doesn't change.
well, that's something else to notice.
Yeah, yeah, so what we were doing is just like, do nice like science analysis, like try one, what's the result, try another one, what's the result. So you can do it that way. Or you can try like.
It wasn't it because the,
M in.
It's more like slightly harder, like in the video.
well, I thought one of the terms was like independent of something.
Oh, yeah. Substitute the equations. Good idea.
Making your own graph.
Yeah.
Yeah. Oh, really? Nice.
But we get like a day and a half of absolutely nothing.
That's true, and it just is the only thing I'm doing is I'm getting into these materials.
Yeah, so there,
That is all.
and there's no.
Actually, no, it's just, I got no more draft. I got ready for
We should go to office hours.
I absolutely am going to office hours.
Yeah, on Monday.
3 seconds.
On Tuesday. Uber's office hours.
Oh.
And now when you run.
No, that's all. No, the worst part is Owen's office hours because the homework's due before his office hours. So like no one can even ask him for help anyways. And the homework before he changed it to Wednesday night, it used to be like Tuesday before class, and he had office hours Wednesday. One, no one would go to that.
That's close to the red line.
What does red line even mean?
Along those lines. So if you print, it's like if you were to print this out, that's the cup where it'll see the text. So if you just keep typing and try to print it out, it will not see the stuff. It adds the thing. It'll just.
Yeah.
So, I was kind of like thinking about it, but
The length doesn't change.
it's normally still like about being negative when it's like changing your rotation, right? Like that would.
So this one's kind of weird, but like very
I wish
rotation.
There's a very
There's
long.
a dairy bar. I was there yesterday.
So like normally we kind of think of vectors.
Like that's just, I like it.
1 meter south of the unit, that's a vector. But you can also say like I'm spinning at whatever 10 radians per second with my head facing east, corkscrewing along the east axis, right? Or corkscrewing perpendicularly, spinning. My axis is the direction, and then the magnitude that I spin is the magnitude.
Yeah.
So you can spin along the axis and have a negative spin. So this is like positive spin.
Unless you're gonna take it negative.
So it's like science street.
Well, it's just describing, like saying, if you're traveling 10 miles an hour east,
Yeah.
10 miles an hour west is negative 10 miles an
And
hour.
like you can't say much about the dimensions.
And that's
The
the
dimensions are just.
They're
Spins the
yeah.
same way.
Unless you're gonna
So
open the
does
door,
like,
that's gonna.
is that modeling rotation? Or,
This one's tracking
12
just
million views.
okay. Oh,
So
okay.
it's
No.
spinning at 15 radians per second.
Yeah.
Then we release the system at time 0, so it immediately starts slowing down. Not super fast, but starts slowing down. And
I
something
feel like someone did send me.
we come to a complete stop. But if we don't let go of the yo-yos, just like let them keep unraveling, they'll continue pulling on us, and then they start
Well, actually, I was
pushing us in the opposite direction.
And that's what makes it negative.
Yeah. Yeah, and then now we've got negative angular velocity.
Yes. Okay. I get that.
Okay, yeah.
But then, like the question is like, why is it negative?
Yeah, why is it negative?
So like, if the yo-yo's trying to is it possible for it to be negative? It's like spinning, or is that just like naturally just spinning down?
You know, the crazy thing about this video,
like
There's
if you
no
increase
physical
time,
no.
I mean, that is.
There's
At
no
some point,
visual stimulation
if you have
whatsoever.
someone
It's
record like
literally
this,
just looking at jackpots. You don't see
you'll
any
come to a
red
stop
signs, anything.
and start spinning
You
in the
might be
opposite
feeling
direction.
great.
And start spinning
I find it
the
funny
same
because,
speed
like,
in the
it's
opposite
just
direction.
Yeah.
Which was not
I do so.
Why is this the most rewatched one?
Like for real?
Yeah, they wanted fried chicken sweet bread.
Yeah, so of course.
What the?
This is the most rewatched thing of the video.
I was pulling on.
Yeah, that sounds like.
There were no signs.
Yeah.
There were no
Yeah.
signs.
You're not gonna get KFC.
I mean, he's a chill guy.
He
We're not like
He does not seem like a.
Bro's just a chill guy.
He was just a little misinformed.
Wait till Mr. Informed finds out.
In that one,
What do you
there's
think?
two ways to think about it, like either
Can you change
conservation
this?
angular momentum,
Oh,
because
that's.
it's a vector.
We did that
So you
actually.
start with 10 kilogram meters squared per second.
I mean, I've got to tell you.
And then we give 10 kilogram meters squared per second to our yo-yos. Now,
Wait, what is
payload has to be 0, and those are 10.
Squared.
But they keep
Radius
going
of
further
what?
out and then moving to see
Oh.
So now they have 20 kilogram meters squared per second.
Oh, by the way,
Total still
I
has to
think
be
I shared
10.
this, but there was some.
We need a negative 10 to make up
like
for the
guns.
20.
Yeah, just like expand.
There's some like push in the movie where like someone's holding like
Yeah.
like
Yeah.
a cartoonish
Just
looking
the
gun.
body.
Yeah, apparently guns are getting.
Yeah.
That makes sense. What's the other way?
Other way to think about it is that those cords that we attach, they're always creating torque. There's some kind of tension. It might not be a lot of tension, but there's tension between our payload and those two yo-yos. So that one's kind of just looking at free body diagram of our payload, where tension torque is an angular acceleration, and acceleration is like a free fall kind of problem. My speed was going up, and then at some point,
So it's like a soundboard?
Yeah, like literally just a sound.
Like capped in the.
If this guy in a radio station, I used to listen every time I'm home, I used to listen to the radio station rock one, they had like some of those.
That one's like a good, like,
They had the most
Yeah.
these two things have to add up to
Like anybody
this.
says anything.
So this bit's big, this has to be negative.
Now, I'm listening to 102.1, 102.9.
102.9 is good.
Those are pretty.
It's more of a math. I would expect you to understand.
This is like 105.
Show you the word,
Is that laser?
like a.
Lasers like
You can trace it,
laser
like right now, it's just like circles. We can see
Yeah, I
showing
used to
a
like that.
circle
I
and
used to watch the morning show, so the guys got older
Yeah.
and less funny.
You have it like the written.
oh, you're looking at like past that time.
I just literally these posts, so
Okay.
that's why it's.
I haven't watched it.
Yeah. Because again, like this is your, like this is looking at a curve where the 0 is your kind of.
I need to find out
where your payload is. Like, so it look like they're spinning faster than you, as you
If
slow
this is
down.
the worst
They're
example,
spinning backwards.
nowhere to go with that.
It looks like they change.
Except in price.
Yeah.
Yeah.
Price is also.
Yeah, it's a
No, I mean
non-inertial.
like from the academic slash
Oh.
emotional niche kind of reference frame. If this is the worst it gets, we're almost done. Next part about rock bottoms is nowhere to go.
How are we doing?
Unless you're reminded.
Last minute questions or answers that we need?
Yeah, we found that the time it takes. Sorry, when you change the starting angular speed, the time it takes changes, but like the length of the cord does not.
Yeah, and that's the best part of this yo-yo design, is that once you have the yo-yo mass and once you have like your payload and you identify like, yes, this is what I'm sending to space and this is the length of cord. It doesn't matter if you're doing 1,000 radians per second or you're doing 3 radians per second. It works. It's the same length of cord, and that part is great. That's why this is such an effective thing. So here, go down, instead of 100, we'll go back down to like 10. And yeah, I still need that 30.49 meters of cord. And a few people have seen this, like your graph gets cut off. There's nothing wrong with that. It's just.
Usually increase the time.
Yeah, exactly.
Do you think like this is useful, like since once we know the required length, we can apply it to any like rotational speed?
Yeah, so it's independent of that rotational speed. Like it'll bring you to a stop no matter how fast or how slow you're spinning. I mean, at some point, if you're spinning like 0.1 radians per second, like barely noticeable, then you're not going to have a lot of centrifugal force to actually get the things off of your spaceship or payload. I say spaceship and payload interchangeably, but something, whatever's in space. if you're rotating really slow, and you're like, release, and nothing happens because everything's almost at zero anyway. Yeah, like if we're at like 0.01, let's try that, see what happens. We'll go up to like 50 seconds. It's still 30.5 meters, but it's going to take us 1,600 seconds for it to actually get to that point because they're moving so slow to begin with, right? Like centrifugal force is theta dot squared.
So the nice thing about like when you even just so like no matter the angular velocity, the length of the rope is constant.
Yeah.
So the nice thing about that is if you put it on like a spool where it just falls off, you don't have to like cut it at a certain time. It just works no matter what.
Yeah, it'll just work.
So the length is dependent on the object and how it's spinning and like
Yep.
the dimensions.
Yeah.
But no matter how fast it's spinning,
Yeah.
the length is the same. That's pretty awesome.
It's amazing that it works so well, and it's a really cheap system to implement because you need fishing line and scissors.
Yeah.
Yeah, and it'll work.
You can just have it run off this like.
Yeah. Well, I'm saying like to design it, like just
okay.
measure certain fishing line, cut it,
The thing
and then
I was like
spool it.
Googling it last night. They use it, but there's like the concern is that it just contributes to space garbage.
It does contribute to space garbage, yeah.
Because I don't know.
Yeah.
You don't need like a huge mass, but it is going pretty fast once you cut it off.
Yeah.
Hurtling through space.
Yeah. It depends on how fast you're spinning.
There's a car
Yeah.
in space. I don't think
Yeah, there is a car.
Yeah.
There is a car.
I don't.
We could put a giant magnet in space.
Do we have space debris tracker? Have you ever seen like a space debris tracker?
I know there are.
Oh, it's right there.
I feel like I've seen some.
Yeah, you can check the car.
Like satellites.
Ah,
I know there's like golf balls in space because some dudes went up to the moon and just started smacking golf balls. That's pretty interesting.
that's cool.
I didn't play golf balls.
Let's see.
Just like watch it fly like that.
If you have a light enough object, I'm sure you could get it to orbit of the moon.
Throw your small friends over.
Because I've seen like live videos of tracking space debris, and even if you make them all, oh yeah, this is probably about right. Even if you make them all like 1 pixel, you can't see the Earth. Because there's a lot of space trash. Yeah.
And that's all since like what? The 60s?
This looks like Wally.
This doesn't look that.
I know.
It's
Yeah.
It's one of my favorites
It's-
of all time, right?
I love Wally.
When he leaves the atmosphere, the rocket just like blasts through all the space garbage.
Yeah.
Goes back and it's just like.
And I think
This thing-
I don't even think this is tracking like all the garbage. Like I think this is just like satellites and stuff that we're putting in. Yeah.
it's
putting up in
and
orbit.
That's all in the last what? 70 years.
Yeah. 70.
No.
Yeah.
How long ago was the
I know there's like some laws in place that when you send, or for the US, if you send a satellite up to space, it needs to like be able to destroy itself after a certain amount of time, or like come back.
But like a dude for self-destruct button on it.
Yeah.
Okay.
There's like a growing demand for like recovering space stuff, like space trash. It's not altruist. It's not like, oh, let's clean up space. It's very much like, we put a lot of expensive things in space. Can we get that back? Like, how do I recover it and sell it? Is more the, our corporate America goal.
We
But-
put a huge.
But if you
net
have
on
if you have an idea for recovering space trash, it's probably like 20, 30 years out. It's like, it's going to be a real business.
So we could be space pirates.
Yeah, space pirates. That's right.
Yeah. Born too late to explore the world, too young to explore the universe.
Yeah.
Born just in time to collect space garbage.
See, and I'll be old enough that I'll actually have a job and have enough money to do that.
this is your job now. You can put a net on the ISS and as it flies around the Earth, it just scoops up stuff.
But then it's gonna lose, then it's gonna gain mass and it'll slow down.
No. I thought it was like, that would have to be like a solid 8 inches.
Yeah, galvanized wired net, galvanized square steel.
Yeah, like the video we have.
Well, no, what do you mean? It can hit different objects and like speed up.
Yeah, I think so. It's like busy. They take a lot of pictures. It looks like I'm finding it took a while, but finding that.
You and the boys watching a husky hang on the space.
In theory, if you're going at the exact same speed as the space, and you just catch it, no problem.
Yeah, we're gonna win already.
I mean, you said it done, but yeah.
Like Elon Musk, you couldn't make it.
There's like a lot of big fresh metals too. Even if like there's no nice electrical components, there's just fresh metals. We're running out of them.
See you later.
Like if you were playing around with how big your mass was, you use that mass to change the layer, yeah, anything else. Yeah, or if there's something like in the path, like that, like if you did something interesting, like these things lined up, whatever, it's open. Yeah, we were talking about like these yo-yos contribute to space debris. Yeah, but it's a lot.
I don't even think this is tracking all of the space debris. That's what I was trying to figure out.